This is Chemistry for Grade 9, produced by Tigray Education Bureau, transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media, and also FM Maqala 104.4.
Hello students, this is Chemistry for Grade 9, presented by Gush Tasfai. Welcome to the third week lesson. Students, do you remember the last week lesson? Good. In our last week lesson, you learned about reaction rate, preconditions for a chemical reaction, factors affecting the rate of chemical reactions, chemical equilibrium, and chemical equilibrium constant expressions. Now, let us begin our today's lesson. Please open your textbook, page 157. Factors affecting the position of chemical equilibrium. Students, state what Lecture's principle mean. Well, students, a system remains at a state of chemical equilibrium if there is no change in the external conditions that disturb the equilibrium. But the point of equilibrium could be affected due to any external factors like temperature, pressure or volume, and concentration. However, Lecture's principle provides a means of predicting the influence of disturbing factors on equilibrium system. This principle states that if a change is imposed on a system in equilibrium, the position of the equilibrium will be shifted in a direction that tends to reduce that change. Then let us explain each factors one by one. 1. The effects of change in temperature on the position of equilibrium. The effect of temperature change on equilibrium depends whether the reaction is exothermic or endothermic reaction. Therefore, an increase in the temperature of a system will favor an endothermic reaction, whereas a decreasing in temperature favors an exothermic reaction. Note that the value of the equilibrium constant is changed or affected by temperature. Let me consider the reaction water gas plus carbon monoxide gas is at equilibrium with hydrogen gas plus carbon dioxide gas plus 41 kilojoule. Since the forward reaction is exothermic, so the reverse reaction must be endothermic. Therefore, if temperature is increased, the system will shift to the left or reverse direction. If temperature is decreased, the system will shift to the right or forward direction, and high yield of products is obtained. 2. The effect of change in pressure on the position of equilibrium. Students, describe the effect of change in pressure or volume on the position of equilibrium. Pressure has effects when the reaction contains gases and number of moles of reactants and products are not equal. Then an increase in pressure or decrease in volume on a gaseous system shifts the equilibrium in the direction of forming smaller number of moles of the gas. But decreasing in pressure or increasing in volume shifts the equilibrium in the direction of forming more number of moles of the gas. Let me consider the reaction. 2 mole of carbon monoxide gas plus a mole of oxygen gas is at equilibrium with 2 mole of carbon dioxide gas. There are a total 3 mole of reactants and a total 2 mole of products. Therefore, increasing the pressure of the system shifts the equilibrium to the forward direction. This results in higher yield of carbon dioxide and decreasing the pressure of the gaseous mixture shifts the equilibrium in the reverse direction. Students, please look at your textbook on page 158 and do exercise 4.16. 3. The effect of change in concentration on equilibrium position. Students, describe the effect of change in concentration on the position of equilibrium. Good. Students, if a reactant or a product is added to a system at equilibrium, the system will shift away from the added component. And if a reactant or a product is removed, the system will shift toward the removed component. In industrial processes, the desired product is often continuously removed from the reaction system to increase the yield. Let me consider again the reaction. Nitrogen gas plus 3 mole of hydrogen gas is at equilibrium with 2 mole of ammonia gas. Removing ammonia or adding nitrogen or hydrogen shifts the equilibrium to the right or forward direction. And if more ammonia is added or removing hydrogen or nitrogen shifts the equilibrium to the left or reverse direction. Remember that catalysts do not affect the position of equilibrium, but they alter the time at which equilibrium is established. Students, explain how Le Chatelain's principle is applied, the Haber process for manufacturing ammonia and the contact process for manufacturing sulfuric acid. Nice, students. Many industrial reactions are reversible reactions. The Haber and contact process provide excellent illustrations of the effect of temperature, pressure, and catalyst on the equilibrium system. Haber process is the industrial production. In Haber process, ammonia is industrially manufactured using gaseous nitrogen. Nitrogen gas plus 3 mole of hydrogen gas is at equilibrium with 2 mole of ammonia gas plus 92 kilojoule. High yield of ammonia is produced by decreasing the temperature and increasing the pressure of the system. However, the yield per unit time is highly increased using an iron catalyst. Therefore, the formation of ammonia is favored at low temperature and high pressure. Contact process is the industrial production of sulfuric acid. Similarly, in the contact process, sulfuric acid is commercially manufactured by the reaction of sulfur trioxide and oxygen. The resulting sulfur trioxide is then converted to sulfuric acid. 2 mole of sulfur trioxide gas plus a mole of oxygen gas is at equilibrium with 2 mole of sulfur trioxide gas plus 169 kilojoule. High yield of sulfur trioxide is produced by decreasing the temperature and increasing the pressure of the system. However, the yield per unit time is highly increased using vanadium 5 oxide catalyst. Therefore, the formation of sulfur trioxide gas is favored at low temperature and high pressure. Question number 1. In any chemical reaction, each type of atoms is conserved. A. True. B. False. In any chemical reaction, each type of atoms is conserved. A. True. B. False. The answer is A. True. Because according to the law of conservation of mass, atoms are neither created nor destroyed. Question number 2. In a balanced chemical equation, both sides of the equation have the same number of moles. A. True. B. False. In a balanced chemical equation, both sides of the equation have the same number of moles. A. True. B. False. The answer is B. False. Because to balance a chemical equation means to equalize the number of atoms on both sides of the equation. Question number 3. The oxidizing agent is oxidized by the reducing agent. A. True. B. False. The oxidizing agent is oxidized by the reducing agent. A. True. B. False. The answer is B. False. Because the oxidizing agent is reduced by the reducing agent, whereas the reducing agent is oxidized by the oxidizing agent. Students, let us to summarize the main points of the unit. Chemical reactions are represented by chemical equations, and the 3 basic laws of chemical reactions are the law of conservation of mass, the law of definite proportion, and the law of multiple proportions. A balanced chemical equation is an equation in which all the number of atoms of reactants and products are equal. Most of the chemical reactions are accompanied by energy change. Exothermic reactions release heat energy to the surrounding, whereas endothermic reactions absorb heat energy from the surrounding. Heat of reaction or change in enthalpy is the amount of heat energy released or absorbed by a chemical reaction. And chemical reactions are classified into combustion reaction, decomposition reaction, single displacement, and double displacement reactions. Stoichiometry is the quantitative relationship between reactants and products. The mass-mass relationship, mass-volume, and the volume-volume relationships are the main types of stoichiometric calculations. Oxidation is the process where a substance loses electron or increases its oxidation number, whereas reduction is the process where a substance gains electron or decreases its oxidation number. Oxidizing agents are the substances reduced, and reducing agents are the substances oxidized. Rate of reaction is the change in concentration of reactants or products with time. Reversible reactions take place in both the forward and backward directions, whereas irreversible reactions proceed only in the forward direction. Chemical equilibrium is the state of a chemical reaction in which the rate of the forward and reverse reaction is equal. Le Chatelain's principle states that when an equilibrium is subjected to stress, the system will shift in a direction so as to relieve the stress. The chemical equation is affected by temperature, pressure, or volume, and concentrations. Students, please look at your textbook on page 161 up to 162 and do the review exercise. Students, this is all about today's lesson. Next week, you will learn Unit 5 State of Matter. Till that time, goodbye.